Okay, welcome back. Today we're going to talk about solving compound inequalities. So first off, we need to talk about what a compound inequality is. A compound inequality is two inequalities that we use together, and they're combined with either the word and or the word or. So either and or or. Now, when we have two inequalities, we're going to just solve them separately. So let's deal with or first, because it can only be written one way. We have x plus 2 is greater than 3, or we'll go 3x is less than or equal to 6. Okay, so we got two inequalities combined with the word and or or. So with or, this is the only way it can be written. You're going to have two inequalities and the word or is between. And all you do is you solve them both separately. So we solve the one on the left. We're going to subtract 2 from both sides. You get x is greater than 1. Or, and on the right, you can divide both sides by 3. X is less than or equal to 2. And that's your answer. The answer will have the word or still in it, and you'll have two solutions. So really, if you covered up everything on the right, you would solve this just the way you do it as a regular inequality. You're going to do the same thing on the left, solve it however you need to solve it as a regular inequality. And you leave the word or in between, and then you circle it as one big statement. X is greater than 1, or x is less than or equal to 2. So that's how you do compound inequalities for or. Now, if it was and, we would actually do the same thing. So one thing you can do is have the word and written here. And when the word and is written here, there is no changes whatsoever. You're going to just solve them both separately, and the word and stays in the middle. But this is not the only way that you can write it. Sometimes you could write the word and like this. 3 less than x plus 1 less than 5. This is also an and statement. So if the word and is actually written out, you're going to solve it like you did the or. If you have it written like this, you need to actually write out both statements. Now there's two sitting here. Now remember, anytime you have the and statement as a compound inequality like this, you're going to have the less than symbols. They could have the lines underneath it to make it less than or equal to. And the smaller number is always on the left, the bigger number is always on the right. And generally the x's are probably going to be in the middle. Here's your two inequalities. One is right here. It says 3 is less than, we'll keep the equals. 3 is less than or equal to x plus 1. So we're going to write that one out. 3 is less than or equal to x plus 1. And, write the word and then the other one is right here. X plus 1 is less than 5. So we're going to write that one out. X plus 1 is less than 5. And now we're back up here. We got two inequalities with the word and. We solve them separately. So we're going to solve them separately. We're going to subtract 1 from both sides. And you get 2 is less than or equal to x. And over here, we're also going to subtract 1 from both sides. And you get x is less than 4. And there's the solution. Now, generally speaking, we want to put it back in this form. So these x's are going to be just one x. We're going to say 2 is less than or equal to x is less than 4. And you can always do it this way, but there's even a shorthand that we can use to avoid writing so much out. And here's what the shorthand looks like. So this is perfectly fine. If you don't understand what I'm about to do, go back to this. It works absolutely 100% of the time. Here's the shorthand. Instead of writing out two equations, we're going to just solve both equations at the same time. And the first thing we did is we got rid of this 1 and we subtracted 1. And when you do that, you do it to both sides. Well, on the left equation, the minus 1 goes over here, because remember, 3 is less than or equal to x plus 1. Right here was our first equation. But we can also solve it over here on the right-hand side, so we're going to put the minus 1 over here. So you have it right here in the middle, on the left, and on the right. So this is like one of the few times where you actually will have 3 spots. And it comes from over here because that's what we did over here on the right-hand side. Okay? So looking at over here, we're going to solve each section separately. On the left, you do 3 minus 1 is 2. That's what we got over here. On the middle, you get 1 minus 1 is 0, so you're just left with x. Symbols stay the same because you did not multiply or divide by negative. And on the right, you have 5 minus 1 is 4. Symbols stay the same, and look at this. Same thing we had down here at the answer. So you're really doing the same work in both of these cases. This just writes more stuff out. If that helps you to keep stuff organized, by all means do it. If you can handle the shortcut and you think this is easier, use the shortcut. But as long as you get the same answer, everything is fine. The only case I want to show you where it might get a little tricky is this one. And let's say that you have, we'll go with 3 and 5 again. That's fine. And let's say in the middle we have negative 2x. Oh, we'll do 2x plus 1. And I did 2x plus 1 just to get rid of the odds. Okay, so we're going to take the middle. First thing we're going to do is get rid of this plus 1. We're going to minus 1. If I do it here, I got to do it to both sides. On the first equation, that's the other side. On the second equation, it's over here. And we're going to subtract. So 3 minus 1 is 2, less than or equal. The 1 minus 1 cancels. I'm left with a negative 2x. And 5 minus 1 is 4. Okay? The next thing I would want to do is get rid of this negative 2. We do that by dividing by negative 2. If I do it here, I do it to both sides. So then the first equation, that's the other side. On the second equation, that's the other side. And we're going to divide. 2 divided by negative 2 is negative 1. This canceled. You're left with x. And over here, 4 divided by negative 2 is negative 2. But remember the rule. If you multiply or divide by a negative, you switch the symbol. So we have to switch these symbols right here. So the less than or equal to is going to become a greater than or equal to. The less than becomes a greater than. So just like before, if you end up dividing by a negative, switch the symbols. However, we don't leave it like this, so we're going to rewrite the whole thing in reverse order, starting with the right. So we got negative 2, switch the symbol around, less than x, switch the symbol around, less than or equal to negative 1. And it means the same thing. This is saying that negative 1 is bigger than all of our answers, x, which is also bigger than negative 2, is the same thing as saying negative 2 is smaller than all of our answers, x, which is smaller than or equal to negative 1. We like this method the best, this last answer the best, because this is the way the number line works. The smaller numbers are on the left, the bigger numbers on the right. You know you're in the right form when you have only less thans. So if you're going to use the combined symbol, only less thans. You may end up with greater thans. Switch it around. Okay, if you have any questions, please make sure you ask, but this is how you solve compound inequalities.